Hello, we are finishing Chapter 1, Section 5, Properties of Exponents. And as I mentioned in the previous videos, we're only doing two skills in each of these first three sections. And these are skills that you're going to be seeing throughout the year. Not in every place, but you're going to see them pop up here and there. And we like to get them out of the way and know what you, make sure that you know how to do them so that we can learn the new stuff when we get to it. In this example, we're going to be talking about the properties of exponents, and we're going to use the properties to simplify. I stole this from Dr. Berger from the book. I just did a screenshot and dropped it in here. By no means do you have to memorize this or anything, and I will have pictures of all these slides available in the same folder that the videos are in, and I'll go over that in class. Or you can just look this up on the book. So I don't need you to memorize this, but I need you to know, I don't need you to memorize the names. I never memorized the names. I learned them after doing them for a long time. But what I need you to understand actually is how it works. Okay? So I'm going to briefly explain each of these, and then we'll try to do a couple of the problems. So the first one's the product of the powers. Basically, it means if you multiply two powers, 4 to the third power and times 4 to the second power, for example, if the bases are the same, which is the 4, then you just add the exponents. Essentially what this means, let me get another sheet of paper here. Oh, not that one. Darn, I put my computer on it, sorry. There you go. Basically what this means is 4 to the third power is 4 times 4 times 4. 4 to the second power is 4 times 4. And if I put them all together, how many 4s do I have? That's 4 to the fifth power. And I get that from 3 plus 2. Same thing happens with the quotient. If I have the quotient property, 3 to the seventh power would be 3 times 3 times 3 times 3 times 3 times 3 times 3. Now you know why we use exponents. 3 to the second power is just 3 times 3. Well, these are going to reduce, and that leaves 3 to the fifth power. So that would be the same as 7 on the top. 7 of the 3 factors on the top. 2 of them on the bottom. 7 take away 2 is going to give me 3 to the fifth power. So those two are the big ones. The power of a power property, hopefully I got some room on this, I'll do it this way. For this example, if I said 4 to the third raised to the second power, that means 4 to the third times 4 to the third, because to the second power means I'm going to multiply it by itself. And if I wanted to expand it, now that looks like this one, but if I still want to expand it, I get 4 times 4 times 4 times 4 times 4 times 4, which is 4 to the 6. So how do I get 3 and 2 and it ends up with 6? I multiply. That's the same as the 3 plus 3 here. So if I have an exponent on another exponent, then I'm going to multiply the powers. The power of a product, believe it or not, we've already used this when we talked about some square root properties. That's the key to simplifying. Basically, this says if I got 3 times 4 to the second power, that means I have 3 times 4 times 3 times 4. And if I put the 3's together, I get 3 squared times, and if I put the 4's together, I get 4 squared. So basically, and this is kind of cool, we don't call it this, but basically this is like distributing exponents over multiplying. Got to be careful though. You cannot distribute, can you guys even see that? Sorry. You cannot distribute exponents over addition, but since you didn't bring it up, I'm going to pretend I didn't bring it up. And finally, I've already used this a couple times in the previous video, whether you saw it or not, but if I have a fraction, a quotient raised to a power, so if I have 3/5 to the second power, that's the same as 3 over 5 times 3 over 5, which is the same as, try to squeeze this in here, 3 squared over 5 squared. So you're sharing the exponent over the division, just like you share the exponent over the multiplying. So like I said, you don't need to write this down or copy it. Practice is where it's going to become important. So let's do a couple problems. And these, before I put this over here, these are going to look nasty. All right. Don't be afraid. It's okay. If you ever get stuck with this, all you have to do is just expand it all out. Write it all out. So if you don't remember what the property is that's going to help you with this one, then just write it all out. 2 times x times x times x times negative 5 times x. Then multiply the 2 times negative 5, put all the x's together. Okay? The property that I'm actually using here, this is, let me rewrite it, make it a little easier. This is 2 times x to the third times negative 5 times x. The property I'm going to use is using the exponents. Remember I talked about in a previous video, you can always show the hidden thing. So there's a hidden 1 right there for the exponent. 3 plus 1 equals 4. So this is x to the 4th power. The constants, the numbers here, the numbers that I know, I can go ahead and multiply that. 2 times negative 5 is negative 10. And I put it out in front. Otherwise it looks like x to the 4th minus 10. You don't want that. Remember, coefficients always go out in front. I'm going to use the properties for this one. I'm going to start with this property, which is the quotient property, because I have a fraction to a power. So that means that the numerator and the denominator both get that exponent. So I get ab to the 4th to the 2nd over b to the 7th to the 2nd. I'm sorry, my marker's starting to get a little thick here. Now, the next property I'm going to use is in the numerator, where I'm going to use, where is it? The product property. So I get a to the 2nd times b to the 4th to the 2nd. And down here I got b to the 7th to the 2nd. Now, I could have skipped from here straight to here if I put them together. Just remember that exponent goes on that, and that. Finally, I'm going to use my power of a power property. I get a to the 2nd. 4 times 2 is 8, so I get b to the 8th power. And 7 times 2 is 14, so I get b to the 14th power. The last thing, which has nothing to do with the properties, is that these b's actually, well, I guess it does have something to do with the properties. It would be starting here and going back to that one. Mea culpa. 8 subtract 14 is negative 6. But we're not going to write negative 6. We're going to put it, remember, negative exponent means reciprocal. So I'm going to write a to the 2nd power with b to the 6th power in the denominator. That's a lot of work. So rewind that and watch that over again, because there's a lot of stuff that happened in there. I went here, then I went here, then I went here. If I was using my whiteboard in the classroom, it probably would have been a lot prettier. Okay. All right, so I've got the product property. So I get 5 to the 3rd power times x to the 6th to the 3rd power. That exponent got shared with both the 5 and the x to the 6. 5 to the 3rd power times 6 times 3 is 18, x to the 18th power. And I can probably go ahead and do 5 to the 3rd power. That's 125, x to the 18th power. And for example D, I get negative 2 to the negative 3 power. I get a to the 3rd to the negative 3 power. And I get b to the negative 3 power. Now, you're probably wondering, could I have done the reciprocal? Could I have done the reciprocal right away? Yes. But I'm going to show you why I didn't do that. And this goes back to anything with properties. As long as you're following the properties, you're going to be okay, right? So this is 1 over 2, negative 2, sorry. And make sure you use parentheses to the 3rd power. This is 1 over b to the 3rd power. But check this out. I get, well, okay, sorry. I guess it would have been confusing the other way for me to explain this. I have the power of a power property, so this is a to the negative ninth power, which is a 1 over a to the ninth power. So I could have put everything 1 over negative 2 a cubed b, and then did that to the third power, because they're all ended up in the bottom anyway. Okay? So I get 1 over negative 8 a to the ninth, b to the third. Okay? And again, I know that this is always confusing doing it like this, so please rewind it, ask questions in the discussion forums, and I'll do my best to explain or talk about it some other way. Okay? We're missing the interactive part in class where you can stop and go, hey, can you say that again? So please use your resources so that we can make sure that you understand this.